All right, guys, welcome to Lab 1, which is entitled Making Graphs in Stata. In this video walkthrough, I'm going to be just going over the analysis section of the lab, but you're expected on your own to complete the methods section of this lab. So since you can't really read exactly what I'm doing, I'll be reading each step of this lab out loud. So the first step is to open Nursing Home Compare in Stata, and to save a new copy of the dataset somewhere on your computer, giving it any name you'd like. All right, so we already did that in the previous lab, so we can already go ahead on to step number 2, which states to identify and explore the data browser and data editor. And we're going to obtain frequency distributions for all nominal and ordinal variables, except the actual identifiers. And so for this step, what we're going to do is obtain frequency distribution for the variables ownership, hospital, and chain. So the first thing, as stated in that question, is to look at the data viewer and the data browser. Right? So if we go up here at the top of our screen, we'll see the data editor and the data browser. So the first thing we'll just do here is click on the data editor. And what that does is pops up an entire spreadsheet of our data set. Right, so all of the data is obtained within here. Now the key difference here between the data editor and the data browser is you can actually change values directly within the spreadsheet in the data editor mode. If we if we switch it to browse, it won't make much of a difference, but as you can see, we're not able to double click and change specific values. All right, so the lab first asked us to obtain frequency distributions for the variables ownership, hospital, and chain. Over here in our do file, I have these codes right here. Right, so we use the tab command, which is just shorthand for tabulate, and we'll do that for all 3 of these variables. And when we execute a command in Stata, we'll go up here to where it says do. All right, and so when we run that, what we can see here are all of the values of that variable. Right, so if you recall, the ownership variable had 12 different values within it. And so we would need to look within our code book as to which value of ownership corresponds to public, nonprofit, or for-profit. And I should add that there are so many codes here because there's more specific categories such as nonprofit, religious affiliated, and also nonprofit, more secular affiliated. So if we look here at the tabulation of the hospital variable, we can see that 157 of the nursing homes in our sample are affiliated with a hospital. And that corresponds to about 10.5% of the cases. If we look at the value of 0, we see that 1,330 of the nursing homes in our data set are not affiliated with a hospital. And that corresponds to almost 90%. Now, finally, if we look at this chain affiliation variable, we'll see 711 nursing homes were not part of a chain, which is about 47.8%. Or for those that were affiliated with a chain, we see that there's 776, or 52.1% of the cases within our data set. All right, so part of what you are going to have to do in your homework and the analytical report is to take these values and express them in some sort of paragraph. Right, so now we'll move on to part 3, which is asking us to recode our measure of quality into a new variable that collapses the original values into the following class intervals: 0 to 11, 12 to 21, 22 to 31, and 32 to 44. And we're then supposed to obtain a frequency distribution for this new variable. Right, and we will do that down here below where it says generating a new deficiency variable. Right, so the first thing we're going to do is create an identical copy of the original variable. That way, we're preserving the coding of that original variable, and any changes we make will be to the duplicate that we made. It's important to not ever lose any of the original data, and it's important to try to preserve that. So if you ever make a mistake in your coding, you can gather exactly where it went wrong, as opposed to just being completely lost because you overwrote that variable. So what this command is going to do is the generate command, and we're going to generate a new variable called defnum1, which is equal to the original variable called defnum. Right, and if we do that correctly, we'll see no red error code or anything like that. And now what we're going to do is recode the values of this new variable into values 0 through 11 are equal to 0, values 12 through 21 are equal to 1, and values of 22 through 31 are equal to 2, and then finally values of 32 through 44 are equal to 3. So we'll go ahead and run that command, and we see that there were 1,389 changes made to this variable. Now, just so we can get a sense of how these variables look, we'll tabulate both the original variable and the new variable. So we'll run the command for both of these, right? And this is our original variable, right? And our original variable of health deficiencies was a continuous variable, right? So you could have 0, 1, 2, 3, 4, 5, so on and so forth, number of deficiencies. But what our new variable did was collapse these across several different bins. Right, so it's just a different way of expressing this variable and collapsing things on certain categories. Right, and so part of what you're going to need to do in the lab is to then write a paragraph discussing these findings. So explain what a value of 0 here means, what a value of 1, 2, and 3 mean. So the next thing that the lab asks us to do is to obtain a pie chart or a bar chart for one of the following nominal variables: ownership, hospital affiliation, or chain affiliation. And so what we're going to do here is both a pie and bar graph. So we'll start with the pie graph first. What this command is telling us is that we want to make a graph, a pie graph, and then we put a comma here over ownership. And what that's telling us is that we want to look at all of the ownership categories within the pie chart. So we'll run that command real quick. And it spits out this really nice basic pie graph. And in subsequent weeks, we'll go over a little bit more detail about how we can edit this graph to our liking. But for the purposes of this lab, we'll just limit it to generating the figure itself. So we'll just go ahead and close that graph. And now we'll go ahead and specify a bar graph through the command graph bar, comma, over chain. So we're going to create a bar graph over the two different categories of chain affiliation. All right, and so here what we see is this is the percentage of nursing homes that are not hospital affiliated, so a little bit less than 50%. And then for those that are hospital affiliated, we see it's a little bit over 50%. And so the final thing that we're going to explore within this lab is a scatter plot. And so the lab tells us to create a scatter plot chart for the following interval ratio variables: defnum, which is the total number of violations, and bed tote, which is the total number of beds. And so down here, I have the command for a scatter plot, and it's simply just scatter defnum bed tote. And so we run that command, And here on the x-axis, we have the total number of beds, and on the y-axis, we have the number of deficiencies. So it doesn't really look like we have too strong of a positive relationship, but it looks like you could either draw a line through this part of the data or this part of the data. Regardless, this is what a scatter plot looks like in Stata, and as should be clear, all of these commands are pretty straightforward and simple. And with that, those are the main things that we're going to be going over for this lab in class. And I hope you guys have a good time completing this assignment.